In this video, we're going to continue our discussion of Taylor&Maclaurin series. The question here is to evaluate the limit as x approaches 0, cosine x minus 1 plus x squared divided by 2 divided by 2x to the power of 4. Now, if you plug in x equals 0, you will see that we get cosine of 0 minus 1 plus 0 squared divided by 2, that's just 0, plug in 0 for x. And in the denominator, we get 2 times 0 to the power of 4, and we get 0 in the denominator. Now, cos of 0 is equal to 1. So we get 1 minus 1, which is 0 in the numerator, and we get 0 in the denominator. This is known as an indeterminate form, which means we have to apply L'Hopital's rule to solve this limit. But in this case, we're going to apply Maclaurin series to evaluate the limit. Now, because this limit involves values of x near 0, we can substitute the Maclaurin series of cosine x and evaluate the limit. So let's start with the Maclaurin series of cosine x. Cosine x is equal to 1 minus x squared divided by 2 factorial plus x to the power of 4 divided by 4 factorial minus x to the power of 6 divided by 6 factorial plus x to the power of 8 divided by 8 factorial. So this is the Maclaurin series for cosine x that we're going to plug in into the numerator here for cosine x. And then we're going to evaluate the limit. So basically what we have is limit x approaches 0, cosine x minus 1 plus x squared divided by 2, all divided by 2 times x to the power of 4. This is equal to limit as x approaches 0. Now we're going to put the first 4 terms of the Maclaurin series of cosine x in the numerator. So we get 1 minus x squared divided by 2 factorial plus x to the power of 4 divided by 4 factorial minus x to the power of 6 divided by 6 factorial. And then we just copy these terms, negative 1 plus x squared plus 2 minus 1 plus x squared divided by 2, all divided by 2 times x to the power of 4. Now, this is very important. We substituted the Maclaurin series of cosine x into the numerator right here. So this is the part that's cosine x. Then this part, we just copy that over. And now we can evaluate this limit because we're just dealing with polynomials. So because cosine x was not a polynomial, we basically represented cosine x with the Maclaurin series, which is really an infinite polynomial. And we use the first 4 terms of the Maclaurin series of cosine x to help us evaluate this limit. So let's do some algebra. 1 cancels with minus 1. Minus x squared divided by 2 factorial cancels with x squared divided by 2. So in the numerator, we just get limit x approaches 0, x to the power of 4 divided by 4 factorial minus x to the power of 6 divided by 6 factorial, and so on, divided by 2 times x to the power of 4. Now let's factor out x to the power of 4 from the numerator. So we get limit x approaches 0, x to the power of 4 times 1 over 4 factorial minus x squared divided by 6 factorial, and so on, divided by 2 times x to the power of 4. But notice x to the 4 cancels from the numerator and denominator. And in fact, that was the factor that was causing the 0 over 0 pattern. That's what was causing the indeterminate form. So we can now just plug in x equals 0. So we have limit x approaches 0, 1 over 4 factorial minus x to the power of 2 divided by 6 factorial, all divided by 2. And this is equal to limit x approaches 0, cosine x minus 1 plus x squared divided by 2, all divided by 2x to the 4. All right, so let's plug in x equals 0. So we have limit x approaches 0, 1 over 4 factorial minus x squared divided by 6 factorial, and so on, all divided by 2. Plug in x equals 0, and we get 1 divided by 4 factorial, divide by 2. Now 4 factorial is 4 times 3 times 2 times 1. That gives us 24. So we get 1 over 24 in numerator, divided by 2. The answer is 1 over 48. So we evaluated limit as x approaches 0, cosine x minus 1 plus x squared divided by 2, divided by 2x to the fourth. And we evaluate this limit, the answer is 1 over 48. So just to review, we basically looked at this part, cosine x, because that's the part that's not a polynomial, and we represented it by a Taylor polynomial of cosine x, a Maclaurin series of cosine x, and that way the polynomials can mix with each other, and we can do some algebra, cancel things out, and find the limit. The answer is 1 over 48. So it may not be clear how many terms of the Maclaurin series to use. General rule of thumb is use the first 4 to 6 terms of the Taylor series. In this example, we use the first 4 terms of the Maclaurin series for cosine x. So we substituted the first 4 terms of the Maclaurin series for cosine x, and then we basically were able to evaluate the limit by using just some factoring and some algebra. All right, thanks.